The circle of fifths is a phenomenon that pops up all over the place in music theory. In fact, we're about to run into it in our next unit on keys and key signatures. And I want to introduce the circle of fifths by thinking about and watching what happens when we move in one direction by a single interval over and over again. Let's start on middle C, and let's suppose we want to move up a minor second from middle C. But we want to do this over and over and over again. We're just going to keep moving up by a minor second and seeing what happens. Well, we'd start on middle C. We'd move up a half step to C sharp, and then up a half step to D, and then up a half step to D sharp, then up a half step to E, up a half step to F, up a half step to F sharp, up a half step to G, up a half step to G sharp, up a half step to A, up a half step to A sharp, up a half step to B, and up a half step to C. So if I start on a note, C, or this will actually work with any other note, and move up a half step over and over and over again, I will arrive back at that same note in one octave. Okay, that's interesting enough. Let's try a different interval, though. Suppose we decide to go up by a major second, and let's start at C again. So we're going to go up a major second over and over and over again. See what happens. So I start on C, go up a major second to D, up a major second brings me to E, up another major second brings me to F sharp, up another major second brings me to G sharp, and then another major second brings me to A sharp, and then one more major second brings me to B sharp. Now, for the purposes of this video, I know I said that B sharp and C are two different notes. And in the real world, they are, at least to some extent. But for the purposes of this video, I'm going to assume n-harmonic equivalence, which means I'm going to assume that B sharp and C mean exactly the same thing. So I'm going to erase this B sharp, and I'm going to do this as I go through various intervals. I'm going to erase this B sharp and replace it full on with the C. Even though we know those are not really exactly the same things, for this demonstration, I'm going to assume they are. So now we have a C, we move up by major seconds, and we end up on the C one octave above. We end up in the same place. And in fact, this collection of notes is known as the whole tone scale. Because it moves up by a whole step and ends up where it started. It's a great scale to know about, and might be something you want to look at in your own music making. It's very cool. But there we see, moving by a single interval, we end up where we started, one octave above. Okay, let's try the same thing with a different interval. Maybe this happens all the time. Let's try a minor third. Let's try a minor third. And again, I'm going to assume n-harmonic equivalence. So I'm going to assume that, say, B double flats and A's are exactly the same. Okay, so minor third means I'm going to be moving up by 3 half steps. So C up by 3 half steps brings me to B flat. Up by another minor third, or 3 half steps, brings me to F sharp. And then another 3 half steps brings me to A, and then another 3 half steps brings me to C. So if I move up by a minor third consistently, I end up where I started. Again, back on that C. And in fact, this collection of notes is known as a diminished seventh chord. We'll talk about that towards the end of the semester. But that is a chord that moves up, or a collection of notes that moves up consistently by a minor third. Okay, this is pretty interesting. Let's see if this holds true for other intervals. Let's try a major third. Okay, so a major third up 4 half steps from C is an E. If we move up another 4 half steps, we end up at a G sharp. And then if we move up another 4 half steps, we end up on a C. Look at that. We end up where we started. In fact, this collection of notes is known as an augmented chord. And we'll see an augmented chord. We'll look at that in a little bit more detail later on in the semester. And then let's take one more, just as a fun experiment. Let's take the augmented fourth, or the tritone, 6 half steps. All right, so if I go a tritone up, or an augmented fourth up from C, I end up on an F sharp. If I go 6 more half steps up from an F sharp, I end up on a C again. So look at that, same thing. As long as I move up by 6 half steps, I will end up on the C 1 octave above. So there seems to be this symmetry that happens every time we move by the same interval. But that's not the case when we look at the perfect fifth and its inversion, or its cousin, the perfect fourth. So in the next video, we're going to see what happens when we conduct the same experiment with the perfect fifth.